Number 6. The diagram shows a vertical tower, OT, of height h meters. The angle of elevation of T from A is 45 degrees, and the angle of elevation from P is alpha. Angle AOP is 120 degrees, and AP equals D meters. The equation to determine the height h in terms of D and alpha is A, B, C, or D. Now we can see from the diagram that angle 45 degrees, that's 45 degrees, that's a right angle, that must be 45. So this is an isosceles triangle, so OA is equal to H. OA is equal to H. Now on the other side here we can see that H over OP, so H over OP is equal to the tan of alpha. So which means, of course, that OP must be equal to H on tan alpha. So now we've got OA, OP, and we know AP is. So we're going to use the cosine rule, and we're going to say that here that this D squared is equal to the OA squared, which is H squared, plus the OP squared, which is H squared on tan squared alpha, minus 2 times H on tan alpha times the cos of 120 degrees. Now I'll rewrite that as H squared plus H squared, and would make that a cot now, cot squared alpha, minus 2 H squared cot alpha. And of course the cos of 120 is negative a half. So tidying all that up, we get H squared plus H squared cot squared alpha. Now this becomes a plus, and the 2's cancel, plus H squared cot alpha. Taking the H squared out as a common factor, we get H squared outside of 1 plus, let's put this in this order, cot alpha plus cot squared alpha. So, and then divide both sides by this, so we get that H squared equals D squared over 1 plus cot alpha plus cot squared alpha. Then finally taking the square root of both sides, we get that H equals D over the square root of 1 plus cot alpha plus cot squared alpha. And that is equal to C.